Hello, everybody. I'm Tamara there, team leader of team 24085. We will have Emily Hom, Porter Bradley, and Sam Weingarten as well, and we'll be discussing our scale-up of KinetiSol processing and pharmaceutical manufacturing. So to start off, there are many small molecule, poorly soluble, active pharmaceutical ingredients in the market right now that have been discovered, basically drug molecules that exist in discovery, but they need further processing to be made bioavailable and soluble to the body before they can be used as actual treatment for patients. One approach to solve this problem is to create solid amorphous dispersions. Those are basically API and polymer blends that take advantage of the amorphous nature of the polymer and the chemical interactions between the drug and the polymer and make it so that the chemical structure of the drug will be amorphous and therefore more soluble and bioavailable to the body. Traditional processes that are leading in the market right now use spray drying, which is a technique that's, again, widely used in the pharmaceutical manufacturing market, but it's very energy and solvent intensive. It requires a lot of organic solvents and a lot of time and energy. KinetiSol is a new novel technology that has been recently introduced to the pharmaceutical manufacturing to make amorphous solid dispersions without the need for solvents, and it has processing temperatures of below melting point to reduce the risk of degradation. So to give a little bit more background about what we have done, KinetiSol has not yet been commercially scaled up to a full manufacturing pharmaceutical process. So we designed a full-scale manufacturing facility to implement the KinetiSol technology into the pharmaceutical manufacturing process. To the side here, we have an image of kind of like how KinetiSol works. It is a fusion-based process that uses shear stresses and energies to create an amorphous solid dispersion from the blend of the polymer and the API. We used abiraterone, which is a hormone therapy drug used to treat prostate cancers, as our model API for the process. It is currently produced as Zytiga by Janssen, but it can be produced just as well with our KinetiSol technology. We used particle sizing, solid powder physical characteristics, drug loading, tablet formulations, and other factors to determine the kind of equipment we use and our flow rates. And we also used our market demand for abiraterone as well as the KinetiSol capacity to determine the sizing of our equipment. Lastly, we compared KinetiSol and spray drying with block flow diagrams, process flow diagrams, and a decision matrix, as well as provided an economic comparison of the two to shed more light about how these two compare.
Our main process contains 5 main unit ops: a roller compactor, which ensures correct particle size and solid powder characteristics for the initial blend; KinetiSol, our main piece of equipment, which creates an amorphous solid dispersion. After being quenched, the amorphous solid dispersion is then milled back into a powder state in the FITS mill. From there, it is sent to a V blender that ensures a homogeneous mix of polymer and API with the addition of lubricant. And finally, a tablet press, which creates our final pill product. In addition to this, safety and purity equipment such as a metal detector and vibro shifter are used after the FITS mill to prevent metal impurity and ensure correct particle size.
In addition to our process flow diagram, we have our block flow diagram, which highlights our flow rates and yields throughout our process. We start by putting 33 kilograms an hour into our roller compactor. And then this is split between 3 different streams to go to our 3 different KinetiSol machines, which have a yield of about 99%. Then the remaining mass that isn't accumulated in the KinetiSol goes to our mill, where we have a 95% yield, and the remaining 5% gets recycled back and is milled again until it's the correct size. And the 95% goes on into our blender, and within our blender, it's added to our other excipients, which represents about 10.35 kilograms an hour. And then once those are all blended together, it goes into our tablet press, and we end up with 41.35 kilograms per hour of tablets. These yields and rates are based on our sizing for our machines as well as our information from our partners at Austin PX.
Our alternative process flow diagram implements a pressure nozzle spray dryer in place of KinetiSol. This pressure nozzle spray dryer includes a mixer that dissolves a powder into a liquid solution where it is sent through a high pressure nozzle atomizer and precipitates into a powder that is further dried in a oven.
So on this slide, we have our comparison of KinetiSol versus spray drying. These are just the parameters that we thought were the most important. So obviously at the top, we have our spray drying versus KinetiSol purchase costs. We determined the purchase cost for the spray dryer based on the evaporation rate and then set a price of $125,000 per machine for KinetiSol to make the KinetiSol process more competitive. So the higher purchase cost of KinetiSol leads to higher capital costs overall, as you can see. For the total energy requirements, spray drying does have about double the utility usage of KinetiSol, but we noticed this doesn't have much of an impact in the overall operating costs. Spray drying obviously requires solvents, whereas KinetiSol does not. So this extra use of solvents adds to the overall operating costs for spray drying. But overall, we can see that KinetiSol is overall a better and more economically favorable alternative because of the higher net earnings and IRR. So here is a summary of our main results for our project. First, we are able to produce abiraterone at a lower price to the consumer than is currently available in the market, but still remain profitable with both processes, spray drying and KinetiSol. Setting our price for KinetiSol machines at $125,000 still gives us higher net earnings and an IRR than spray drying. Our production and overall maintenance costs are decreased with KinetiSol, and overall the lack of solvent usage leads to a greener process, eliminating the use of these and also reducing waste as well. Because of the upscale of our process, we are able to efficiently finish the production for the entire yearly market demand of abiraterone in only 3 weeks. And lastly, we are able to expand the production and our KinetiSol process to a bigger list of small molecule poorly soluble crystalline API.
To conclude, we are able to successfully incorporate KinetiSol into manufacturing process for abiraterone. We are also able to extend this process to some other compatible APIs. We found that KinetiSol was greener, had enhanced bioavailability, was more time efficient and more economically favorable than spray drying. In the future, we look to extend the KinetiSol work to even more APIs and to also incorporate inline quality testing so that our process is better. Thank you all for listening to our presentation.